Hello guys, welcome back to my channel Mason African Motives. Still working on the question paper which was written on the 4th of February 2022 for mathematics N3. So that is what we have guys for mathematics N3. So we are going to focus on this question paper. So it's a continuation, if you still remember, from the last part that we worked on. So in this case we are going to continue. Okay, so we shall quickly rush through the questions. Okay, so in this case we shall focus on question 4, that is a continuation from where we left. Question number 4, we are given to consider figure A. Below, A, B, C, D is a trapezium. So we are given that A, B, C, D is a trapezium. That is the shape that we are given. There is a trapezium. And where AB is parallel to CD. Okay, so take note that AB and CD are parallel with the vertices A. We are given the vertices for A, B, and also the point C. We are having the point C and also the point D, which is 9, 8. C is the y-intercept of the line CD, that is the line CD, and line BC and also line BC. So as you can see, this is the y-intercept of the two lines, where P is the x-intercept of line CD. Okay, the line CD, this is our point P, which is the x-intercept. Okay, so that is what we have from this part. And the first question that we are given is to calculate the length of the line segment AB. So let me just try to adjust there. So it's the length of line segment AB. Okay, we have the point A and we also have the point B. So we know that the length from this part, you can take it from your formula sheet. This is what we have for length, or the distance about a straight line. If you are given that's a straight line, so where we are given distance there, that is the formula that you are going to use for length. So we need the length of AB. So length AB is going to give us from the formula that we are given, it's x2 minus x1 squared plus y2 minus y1 squared. Okay, this is everything under the square root. So we have the point A from the diagram. Our point A is represented by the point 5, 13. This is point A. The point B is represented by the point -1, 5. Okay, so in order for us to have x1, x2, y1, and we have to name this point to be x1, y1, x2, y2, so that we can substitute into the formula. To substitute is to simply put in the values according to the way that we are given. So x2, in this case x2 is -1, so it's -1 minus x1, x1 is 5 squared, plus y2, in this case y2 is 5, so we're going to have 5 minus y1, which is 13, everything squared. That is what we are going to have in this case. Okay, so what are we going to have? If we are to simplify, we are going to remain with the square root of, in this case, if we are to simplify, we can just simplify the part which is under the square root. So from the part that is under the square root, we have the square root of, in open bracket, that's -1 minus 5 into bracket squared. Okay, so in this case plus, we have 5 minus 3, 5 minus 13. This is 5 minus 13 in bracket also squared. Okay, so since in this case we have written the square root already, I have written the square root, if you can take note. So I'm going to remove the square root and just work with this part. So I'm going to have the square root of 100. So from square root of 100, I'm going to obtain 10. That is the square root of the answer that I have obtained there, which is 10. So we are going to have 10, which is the length AB. And take note that the length is given in units. So it's going to give us 10 units. That is the length of AB is 10 units. Okay, so that's what we have in this case. Then we move on to the gradient of line AB. Okay, still with the same point that we have A and B. This time we need the gradient of the line AB. So remember, gradient is given by the formula y2 minus y1 over x2 minus x1. That is the gradient formula. So we have to substitute in this case y2, which is 5. So we have 5 minus y1, which is 13. So we have 5 minus 13 over x2 minus x1, in this case x2. That's minus 1 minus x1, which is going to give us 5. So we are substituting from what we have. So in this case, from our calculator, this one you can just use your calculator, guys. So put a fraction there. We have 5 minus 13 on top. That is on the numerator. On the denominator, we have minus 1. That's minus 1 minus 5. Okay, which is 4 over 3. So we are obtaining the gradient of line AB being 4 over 3. Okay, then we are given to find the equation of line CD, leaving the answer in the form of y is equal to mx plus c. Okay, we need to find the equation of the line CD, and we are to give this in the form of y is equal to mx plus c. Okay, line CD, we are given that CD and AB, they are parallel. These two lines, CD, if you can cross-check lines from C to D and from A to B, these two lines are parallel. So if these two lines are parallel, what do we understand about parallel lines? These things you are given from your formula sheet, everything is written. On your formula sheet, it's written that for parallel lines, M1 is equal to M2. What do they mean when they say M1 is equal to M2 for parallel lines? It means that the gradient is the same, because M represents the gradient. So the gradient for parallel lines is equal, or the gradient for parallel line is the same. So if lines are parallel, if they possess the same gradient, what are we going to use here for CD? Since we have the gradient of AB, because we calculated it before, we can use the gradient of AB on the gradient of CD. Okay, so in this case, we are saying that from parallel lines, that means MAB, the one that we calculated, is equal to MCD. The gradient of line AB is equal to the gradient of CD. From M1 is equal to M2. So that means the gradient of CD is going to give us, since we calculated the gradient of AB before and obtained 4 over 3, so our answer is going to be 4 over 3 for the gradient of what? Of CD. But we are given to find the equation in this format. Since we are to write this equation in the form of y is equal to mx plus c, we are now going to substitute the values that we are given, since we say that the gradient of CD in this case is the same as BD, which is 4 over 3. So we're going to substitute in M, since M represents the gradient. So it's going to be y is equal to, in place of M, we substitute the gradient, which is 4 over 3 x plus c. So guys, take note on this part. We need to find the value of c. This is the remaining value, because y and x, these are the variables, but c, it's a constant. You need to find its numerical value. So where are we going to find this value? We are going to substitute any point that you are given on the line CD. So if you are to cross-check on line CD, we have the point 98. So we can substitute that point D, which is 98. What does this mean? This is a point which is written in terms of x and y. So we have the value for x and the value for y. So you are going to substitute in place of y, you substitute y, which is 8 is equal to 4 over 3 by x. X is 9, so you're going to multiply by 9 plus c. Okay, so we are going to have 8 minus 4 over 3 times 9. What do we have from our calculator? That's 4 over 3. You can use our calculator to simplify. 4 over 3 times 9. 4 over 3 multiplied by 9, we are going to obtain something like 12 in this case. So we're going to have minus 12 equal to c. We are supposed to have 8 is equal to 12 plus c. Since this is if you take it to the other hand, is going to give us a negative. Okay, so c is going to give us, if you subtract from your calculator, you are going to obtain minus 4. So you can now substitute the value for C of C that you have obtained in C. So therefore the equation of the line CD is going to be in the form of y is equal to mx, which is 4 over 3x, plus C. Our C is minus 4, and plus and minus gives us a minus, so it's going to be minus 4. So y is equal to 4 over 3x minus 4. That is what you are going to obtain from this part. Okay, then the coordinates of C, the y-intercept. Okay, now we need to find the coordinates of C, which is this point C, the y-intercept. So take note, C is the y-intercept of both lines, the line ACD and the line CB. So you can take advantage of the equation that we have found, in this case. This equation is the equation for the line CD. So remember, the y-intercept is on a condition where x is equal to 0. That is where we find the y-intercept when x is equal to 0. So when x is equal to 0, if you are to substitute a 0 in this case, what are we going to have? We have 4 over 3 times 0, which is 0 minus 4, which is minus 4. So y is going to give us minus 4. The y-intercept, x is equal to 0. So this is a point that we are calculating, which is C. So remember, a point is given in terms of x and y. So x is 0, y is minus 4. So that's the point C, which is 0 minus 4. So in actual sense, this point C is 0 minus 4. That is what we have. Okay. The equation of the line in the form of y is equal to mx plus c, which is perpendicular to CD. Okay, let me just try to adjust once. Okay, so we are given that to find the equation of the line in the form of y is equal to mx plus c, which is perpendicular to CD and passing through the point C, and we have 3 marks for that. Okay, take note that this equation that you want to calculate is perpendicular to CD. This is the line CD. Perpendicular to CD like that, it passes through the point C. That is the part which is important, that it has to pass through the point C. Okay, so what we have, we know that for perpendicular lines, also it's there on your formula sheet for perpendicular lines, that if lines are perpendicular, M1 by M2 is equal to minus 1. That is, the product of gradients gives us a negative 1 if lines are perpendicular. So in this case, we are given that line CD is perpendicular to this line that we are talking about, and we have the gradient of CD. So the gradient of CD, we obtain it as 4 over 3. Multiply by the gradient of the line that we are talking about, which we do not know. We are going to obtain the gradient of minus 1. We are going to obtain the product of minus 1 if we multiply these two. So what is M2, which is the gradient of this line that you're talking about? So simply to remove this 4 over 3, you can divide by 4 over 3, or you can multiply by 3 over 4, or you can just divide by 4 over 3 like this. So that means M2 is equal to minus 3 over 4 from your calculator, or the inverse of 4 over 3, which is minus 3 over 4 in this case. So we have the gradient now, and we are given that this line, it passes through point C. So we have the gradient and the point that this line is going to pass, which is C, which is 0 minus 4. So the point C, we know that it's 0 minus 4. So we now have two properties that can help us to find the equation of a line. We have the gradient, and we have a point where this line is going to pass. Okay, since we are given that our equation is supposed to be in the form of y is equal to mx plus c, we can just substitute what we have. In this case, m2, we have the gradient, which is m2, the gradient, which is minus 3 over 4. So we are going to write y is equal to m, which is minus 3 over 4x, plus c. C represents the y-intercept, so you can write plus c, or you can just write the y-intercept, because c represents the y-intercept. The y-intercept is minus 4, so it's going to be minus 4. So this m is the gradient, and this c is the y-intercept. y-intercept. Okay, so that is what C represent. Or you could have just written it as y is equal to minus 3 over 4x plus C. Then you substitute the point C that we are given, which is 0 minus 4, where you have the value of x and the value of y. So if you substitute in place of y, we have minus 4. In place of x, you substitute 0. So it's going to be minus 3 over 4 by 0 plus C. Any number times 0, that's a 0. So which means C is going to give us minus 4. So if C is giving us minus 4 in this case, we are now substitute into this part, which is y is equal to minus 3 over 4x plus and minus, we obtain a minus, so it's going to be minus 4 like that. Take note, that's what we had for this part. Okay, then the coordinate, the x coordinate of P, the x coordinate of P, this is P, we are talking about the x coordinate. Okay, remember the x coordinate is a condition where we have the point in the x-axis, and in the x-axis y is equal to 0. Always in the x-axis y is equal to 0. So if y is equal to 0 and we have the equation, because this x-intercept that we are talking about, P, is the x-intercept on the line CD. So we focus on equation of line CD, of which the equation of line CD, we obtained that equation before. We said it's y is equal to 4 over 3x minus 4. This was the equation of line CD from item 4.3. So if this is the equation of line CD, and we are saying for the x-intercept, y is equal to 0. So if y is equal to 0, what is going to be the value of x? That is what we are simply asked in this case. So it's a matter of substituting. In place of y, we substitute 0. So 0 is equal to 4 over 3x minus 4. And you want to calculate x, so you're going to take minus 4 to the other side, is going to be a positive. So 4 is equal to 4 over 3x. So to find x, you can cross multiply, or you can just divide by 3 over 4, or you can just cross multiply, because 4 is same as 4 over 1. So if you cross multiply, is 3 by 4. 3 by 4, which is 12, is equal to 1 times 4x. These two multiply, 1 times 4x, which is 4x. If we divide by 4 to obtain x, if you divide by 4, it's 4 into 12, or 12 divided by 4, which is 3. So the value of x is 3. Remember, we are given to find the x coordinate, so you just write the value for x, that x is equal to 3. You don't write it as a point. If you are given to find the point, that's when you write it as 3, 0. Okay, that's what we had for this part. Then we move on to calculate, determine the size of beta, the angle of inclination between CD and the x-axis. This is our line CD and the x-axis. This is the angle that we are referring to as beta. So remember, the angle of inclination, also from your formula sheet, the angle of inclination is given as theta is equal to arctan m. But here we are not given this angle as theta, we are given this angle as beta. This is beta, this one. So we are going to write beta is equal to arctan m, which is m, that is the gradient. So which gradient are we referring to? We are referring to the gradient where this line, this angle is between line CD and the x-axis. So we are talking about the gradient of CD. So we are going to use the gradient of CD. So that means beta is going to give us arctan, the gradient of CD. Remember, from from the equation of CD, we obtain that the gradient of CD is 4 over 3. We obtain this one is 4 over 3. So that is going to be our beta. So it's arctan 4 over 3. So we have arctan. Make sure that your calculator is in degrees. Arctan is shift, tan, shift, then tan. Okay, shift, then you press this tan. That is arctan. Okay, 4 over, you put the fraction 4 over 3, then you can close that bracket. So you are going to obtain 53.130 and so forth. Okay, so this is your beta, the angle, which is 53.13 degrees. Okay, so this beta, the angle that you're talking about, is this one. That is the one that you're talking about, 53.13 degrees. Okay, then the other part is to find the size of angle, alpha, or angle OCP. Angle alpha, this is our angle alpha, which is OCP. Okay, if you are to take note from this angle alpha, in order for us to find alpha, let's take note. Here we have the y-axis and the x-axis, they meet at point O, which means this angle O is going to give us 90 degrees. Remember, perpendicular line and a vertical line, when they intersect, they intersect at 90 degrees. Then this angle P inside this triangle is the same as this angle beta y, because these are vertically opposite angles, they are equal. So this angle is same as 53.13. This angle is same as 53.13. So in order for us to find alpha, as you can see, we are given two angles and we are remaining with the third angle. So we are going to use the properties of a triangle to say that in a triangle, angles add up to 180 degrees. So if angles add up to 180 degrees, therefore the alpha that we are talking about is going to be the total when it comes to angles minus the two angles that we are given. And which two angles are we talking about? We are talking about this angle of 90 degrees. So we have 90 degrees plus another angle, which is this angle at P, which is the same as the angle 53.13 from what? From vertically opposite angles. So we have 53.13 degrees. So this is what you are going to have, and from your calculator, this part you can just simplify it direct. That's 180 minus open bracket, that's sine, that's 90 plus 53.13, 53.13, close the bracket. Then we have this, convert to a decimal, is 36.87. okay, which is 36.87 degrees. That will be the angle alpha. That is what we had for angle alpha. Okay, then the other question we were given, question 5, which is a continuation, question 5, where we are given to draw the graph of y squared is equal to 4 minus x into 4 plus x, showing the intercepts of the axes. Okay, this question, most of us, we confused something which was very, very small. Let me just explain about that part. If we are to cross-check on this equation that we are given, we do not know that it's a parabola or hyperbola, a straight line or whatever, because we haven't simplified anything. So let's try by all means to first simplify what we have. We have brackets, and from these two brackets that we have, they are special type of brackets. We only found this condition from difference of two squares, where the two numbers or the two terms are the same, but only one bracket is having a positive, another bracket is having a negative. It's only under difference of two squares, where we know that this number were taken from 4 squared minus x squared. These were the two terms that we had, which ended up giving us 4 minus x and another one being 4 plus x. But we know that 4 squared is 16 minus x squared. So that is what we have. But if we are to cross-check properly, this type of an equation is very, very similar to this equation of a straight line, of a circle, where we are given this equation in the form of x squared plus y squared is equal to r squared. So if we are to write in this format, you find out if you are to take minus x squared to the left hand side, is going to be positive. So we have x squared plus y squared equal to 16. So what do we have? This is a circle. It's a circle that we are having, where we know that for a circle, to find the intercepts when x is equal to 0, we are on a condition that x is equal to 0, we are going to remain with y squared equal to 16. And to find y, that will be introduce the square root, which is y is equal to square root of 16, which is plus or minus 4. Remember, square root of any number is plus or minus. The same applies when y is equal to 0, we find the values of x. When y is equal to 0, we shall have x squared equal to 16, which is going to give us plus or minus for square root. So as you can see, it's a circle which is bounded from plus to minus 4, plus to minus 4. So what you can simply do is to just draw your circle. Since this type of a circle has the center as the origin, you are just going to draw a circle of your choice. Okay, then you indicate the points. Now we have 4, minus 4, minus 4, and 4. So this is the y-axis and this is the x-axis. So that is the circle for y squared is equal to 4 minus x, 4 plus x. So when you're writing, you write the equation that you were asked. Yes, we simplified, we expanded brackets so that we can write in a clear way, but you write the equation on your answer. You write the equation of the question that you were given. Okay, so in this case we have to produce a circle. Okay, so on 5.2 we are given to determine the y/x of the function, that is the function that we are given, by making use of the rules of differentiation. The final answer must be with positive exponents and in said form where applicable. Okay, in this case we are given two important things: to leave our answer in terms of positive exponents and to leave our answer in said form whenever it is applicable. For this question, we want to find the y/x. Whenever you are working with the derivatives, guys, take note that you have to first simplify in a format that you understand. The format that I'm talking about is the format of ax to the exponent of n. That is the format that you must have your expressions in. So in order for us to have this format, we are going to have y equal to x to the exponent of 4. From our laws of exponents is same as to the exponent of minus 4. So we are going to have 1 over 2 x to the exponent of minus 4, like this. Okay, minus 8 square root of x. From our laws again, square root of x is same as x to the exponent of a half. Remember, we need to write in terms of a x to the exponent of a certain number. That is the way that we are writing. We have a x to the exponent of a number, a x to the exponent of a number, okay, plus ax. So take note, in this case we haven't started differentiating. We are just rewriting in a way that we can actually work with to differentiate. Now let's differentiate. We know that from our y/x we are going to drop this exponent to multiply this number, so it's half times minus 4. From your calculator you are going to obtain minus 2 x to the exponent. Remember, when you multiply these two, you subtract 1. So from your calculator, minus 4 minus 1 is going to give us minus 5. Okay, we do the same. We drop the exponent. Half is going to multiply 8. So from your calculator, minus 8 times a half is going to give you minus 4 x to the exponent of, we subtract, that's a half minus 1, which is going to give us minus half. Okay, plus ax, the derivative of x, remember we take the constant if it is just x like that, so we're going to have plus a. So we're at this stage, that is now when we have to apply what we are given, that our answer must have positive exponents and in said form where applicable. Here we have negative exponents, so you have to get rid of these negative exponents. Okay, so that means our y/dx is going to give us, here we are just simplifying. This is our answer, but now we have to write in the format that we are given. So remember, x to the exponent of minus 5, we took it from over x to the exponent of 5, so it's going to be minus 2 over x to the exponent of 5. Okay, this one we are going to have, this part we are supposed to write it as minus 4 over x to the exponent of a half from that negative half. But we know that x to the exponent of a half is same as the square root of x. x to the exponent of half is same as square root of x. So this one is going to be written as minus 4 over square root of x. That is the said form now. So we have minus 4 over square root of x plus a. So that is how you can actually leave your answer in terms of positive exponents, and in terms of what? In terms of sets. To leave your answer in terms of in set form is to leave your answer under the square root. Okay, so that is what we had. Then on number 5.3 we're given that f of x is 6x squared plus 2x cubed. Then we are asked to determine the coordinates of the turning points, the roots of the graph of f of x, then sketch the graph. Okay, so that is the expression that we are given for f of x. We are given that our f of x is equivalent to 6x squared plus 2x to the exponent of 3, which is 2x cubed. Remember, when you are working with the turning point, the first equation is asking us to calculate the coordinates of the turning points. Remember, the coordinates of the turning points occurs on a condition where the first derivative, or dy dx, is equal to 0. So if the first derivative is equal to 0, that is why we are having the turning points. So in this case, we have to find the first derivative and equate it to 0. So let's differentiate. 2 is going to multiply 6, that's 2 times 6, which is 12x. If we subtract 1, it's going to be 1, which is just 12x, okay? Plus, we multiply 3 and 2, 3 by 2, which is 6. X to the exponent, we subtract 1, which is going to give us 2. So this is the first derivative, which we are saying is supposed to be equal to 0. So we have an equation now that we are going to formulate. 12x plus 6x squared is equal to 0 from this part. Factor out the common term in this case, which is going to give us 6x, that is the highest common factor. So it's 12x divided by 6x, which is going to give us 2. That's 12 divided by 6 is 2x, and x cancels, plus 6 and 6 cancels, x squared divided by x, which is x. We are going to have 6x into 2 plus x equal to 0. So equating the expressions that we have to 0, we are going to have 6x equal to 0, or 2 plus x equal to 0. So in this case, if we divide by 6 by 6, our x is going to be 0, or from this part, x is going to be equal to 2. If we take it to the other end, it's going to be minus 2. So these are the values of x that we are having at the turning points. But remember, the question is asking us to calculate the coordinates, where we know that the coordinates are given in terms of x and y. So you substitute now the values that you have obtained of x into the normal function of f of x. So we are going to find f of 0 when x, because we have x when x is 0, we are going to find f of 0 in this case. We substitute into the normal function, this one, of f of x, which is 6x squared plus 2x to the exponent of 3. When x is equal to 0, there you are going to obtain a 0. So that's a 0.00. We substitute when x is equal to minus 2. So it means f of minus 2. In place of x, if we are to substitute minus 2, is going to be 6 into minus 2. That's 6x squared. So it's 6 into minus 2 squared plus 2 into x, which is minus 2 to the exponent of 3, or to the power of 3. That is what we are going to obtain in this case. So simplify this part using your calculator. We are going to have 6 into minus 2 to the exponent of 2 plus 2 into minus 2 again, but this time to the exponent of 3. Okay, so we are going to obtain 8. So we are going to have our y as 8. So the point is going to be minus 2, 8. When x is minus 2, y is 8. So these are the points that we are obtaining, that is the turning points for this function of x from our f of x. Okay, then we move on to the roots of f of x, the graph of f of x, the roots of the graph. Okay, we know that the roots, these are the solutions which occurs when f of x is equal to 0. These are the solutions, and our f of x is 6x squared plus 2x to the exponent of 3, which is equal to 0. So what are we going to have on our roots? Okay, 2x is common. 2x squared, in fact, is common in this case. So we are going to factor out 2x squared, which is the highest common factor. 6x squared divided by 2x squared, that's 6 and 2, which is 3, plus 2 and 2 cancels, x cubed divided by x squared, which is x, equal to 0. So from this part we shall have 2x squared equal to 0, or this is 2x squared equal to 0, or 3 plus x equal to 0 again. So from this part, if we divide by 2, square root of 0 is 0, so x is going to be 0, or x is going to give us minus 3. So in actual sense, on this part there are two values that we are obtaining of 0. So take note that one is going to give us something like where it's going to be a turning point at that point where x is equal to 0. So we are asked to find the roots, so these are the roots, x is equal to 0 or minus 3. So this one you can even write it as 0 twice or minus 3. Okay, then we have to sketch the graph now. So in order for you to sketch the graph, first let's see what we have. We have the solutions in this case. The solutions, these are the ones that we obtained. X is 0 and x is minus 3. So when x is 0, we have another x here, which is minus 3. But take note, this 0 is also a turning point, because we are given the turning points in this case. 0, 0 is a turning point, so this point is also a turning point. It's a solution and also a turning point. Another point, a turning point, is in between minus 2 and 8. So let's assume this is minus 2 and 8 somewhere here, because y is positive. So let's say this is minus 2, 8, another turning point. This is also a turning point. So if these are the solutions and this is a turning point, definitely the function that we shall have in this case is going to be in this format. At this point, it's a turning point, so it's going to move this part like this. So we have a turning point at 0 here. So 0 is a solution and also a turning point. Minus 3 is just a solution. This one is also a turning point. So these are the points that you're asked to show all the intercepts on the axis and the turning point. So also for the intercepts, when our x is equal to y is 0, so it's also the intercept and the intercept, the turning point, the solution. This point is representing about 3 things that in this case. So this is the function of f, which is f of x. That is what we were supposed to obtain a sketch like that one. Okay. Then on number 6.1 there, we are given to make use of trigonometric identities to prove that. Okay, let me just write that identity so that we can work it together. It can be easier that way. We are given sec plus 1. This is sec x plus 1, equivalent to 2 cos x. That's 2 cos x times cos x squared. Cos x squared x. Okay, so remember that when you are working with identities, to prove a certain identity, you have to choose a certain side that you are going to work with. So in this case, I'm going to choose working with the left hand side. So we want to prove from the left hand side that we are going to obtain what is on the right hand side. You have to choose the part that we work. So if we are to choose the left hand side, we are going to have something like 1 over, that is sec x minus 1, plus 1 over sec x plus 1. That is what we had on the left hand side. Okay, let's find the LCD, since these two are actually adding. So we have to find the LCD, which is going to be sec x minus 1 into sec x plus 1. So you simply take these two that you are given. Okay, so we are going to divide our LCD divide by this sec x minus 1. So sec x minus 1 will cancel. You remain with sec x plus 1 times 1. which will remain as sec x plus 1 plus sec x plus 1 and sec x plus 1 will cancel. You remain with sec x minus 1 times 1, which is sec x minus 1. Okay, this is the stage that we are at now. Now let's collect like terms. 1 minus 1, that's a 0. Here we have 1 sec x plus 1 sec x, that is sec x plus sec x, which is going to give us 2 sec x, over here. If we are to cross check, sec x minus 1 sec x plus 1, this is difference of two squares. If we are to cross check, if you are given a squared minus b squared, remember it's a minus b, a plus b. So which means this part, that is the one that we have a, if you are given a minus b and a plus b, you can reverse it back from the difference of two squares, which is the same as what we are given, sec x minus 1 sec x plus 1. This is our a, this is our b, this is our a, this is our b. So it's going to give us a squared, which is sec squared x, minus 1 squared is 1. Okay, from our identities we can replace sec squared minus 1 with its equivalent identity. Remember, 1 plus tan squared x gives us sec squared x. So in order for us to have sec squared x minus 1, we have to take 1 to this side, so that we remain with tan squared x being equal to sec squared x minus 1. So in place of sec squared minus 1, you now substitute with tan squared x. So this part is going to be substituted, or is going to be represented by its equivalent, which is tan squared x. Okay, so what are we going to have? We are going to have, from this stage, you can continue in your book, but here I'm just writing separately. From this stage, you are going to have 2 sec x, 2 sec x over sec squared minus 1, which we said is the same as tan squared x, the one that we obtained from this identity here. You replace with tan squared x. Okay, what do we have in this case in actual sense? Remember, sec, whenever you're given sec, is same as 1 over cos. So we can actually write this as 2, in place of sec like this, is same as 2 over cos x. But already we have tan squared, which is the one that we have here. So it's going to be cos x of by tan squared x. Okay, but we understand that tan is same as sine over cos, but there's a square in this case. So we are going to have, in place of tan, since it is sine squared x over cos squared x like this, if we are to write this part here, we are going to have something like 2 over like this, cos x by tan squared x, which is sine squared x over cos squared x like this. Okay, what do we have? What are we going to have from this part? This one is same as over 1, so cos x into cos squared x, you are going to remain with cos x. So we have 2 over sine squared over cos squared. So since this is one term or one expression, we can rewrite this in a simpler way, like 2 divide by, because we are dividing sine squared over cos x. So you can just write it as 2 divide by sine squared x over cos x. And remember, when you are dividing, you introduce multiplication. Once you introduce multiplication, you invert your fractions. So it's going to be cos x over sine squared x like this, and this is same as over 1. So if you multiply 2 times cos x, we are going to have 2 cos x. And whenever we have over, because this one is going to be 1 times sine squared, which is sine squared, and 1 over sine squared from our identities, remember 1 over sine x gives us cosec x. So if it is 1 over sine squared, it's going to be cosec squared also. So in place of over sine squared, it's going to give us cosec squared x. So this is what we have at the end, 2 cos x by cos squared x. As you can see, this one is equivalent to the right hand side that we were given. Okay, that is what we had. Then on fig B, below A, B and C, D are two towers which stand on the horizontal plane. This is the horizontal plane. We are given the angle of depression of D is 30 degrees. So take note, if this is the angle of depression of 30 degrees, it also means this angle here is going to give us 30 degrees also. Okay, then we are given the angle of elevation of C from B. This C from B, looking at this point B, it's 45 degrees. And we are given that this is 90 and this is 45. So definitely this one is going to give us 45 degrees also. Since we know that angles in a triangle, they add up to 180 degrees. Okay, then we are given that AB is 50 square root of B. AB is 50 square root of B. Find the height of CD. Okay, want to find the height of C to D. Okay, let's cross-check something here, guys. From the triangle that we are given in this case, this triangle that we are given from A, B, D, since we say this angle is 30 degrees, we can take advantage to first calculate this side BD from our trigonometrical ratio. Since we have an angle and another side, according to this angle, this side that we are given is the opposite, and this side that we want to calculate is the adjacent according to this angle, because it's a right angle triangle. We are using this angle of 30 degrees that we said is the same as this one from alternate angles, because these two lines will be parallel, and if they are parallel, these two angles are equal alternate angles. So which ratio uses opposite and adjacent, or from SOHCAHTOA, or from that SOHCAHTOA, opposite and adjacent is obtained from tan theta, which is opposite over adjacent. So this one is from SOHCAHTOA, like this. So we have tan is opposite over adjacent. So in this case, tan theta, our theta is the angle that we used to obtain this, which is tan 30 degrees. So tan 30 degrees is equal to opposite. The opposite that we are talking about is 50 square root of 3. So we have 50 square root of 3 over the adjacent, which is BD or DB. So we have BD in this case, this side that we are given, that we want to calculate, so that it can help us to calculate the actual side of CD. Okay, so if we are to cross multiply, we are going to have this one is over 1. So we have BD tan 30 degrees, which is equal to 50 square root of 3. So in this case, in order for us to find BD, we are going to divide by tan 30. So it's going to be 50 square root of 3 divided by tan 30. So in this case, using your calculator, it's 50 square root of 3. Everything in this case, let's put a fraction, over tan 30, because we are dividing by this tan 30, which is multiplying. So divide by tan 30. Make sure that your calculator is in degrees. So you are going to obtain 150. And as you saw that our units, we are not given units, it's just the dimensions. Here we are not given the dimensions, it's just the size. So we are just going to write our BD as 150. Okay, why are we calculating BD if we know that BD is 150, guys? Can we not calculate this side CD? Is there need for us to calculate the CD? There is no need, because we said this angle is 45 and also this angle is 45, which means BCD is an isosceles triangle. This side CBD and this side CD, they are equal from the base angles that we are given. So if this side is 150, it actually means this also is 150. That is our CD. So the CD that we are asked in this case is going to give us 150 from what? From the isosceles triangle, the base angles are equal, and from the base angle, this angle corresponds with 150, this angle 45 corresponds also with 150, which is CD. Okay, so as you can see, guys, this is how they ask these questions. Be very careful the way they ask these questions. So that is what we are given for this question paper, which was for February 2022, mathematics N3. So if there are still some areas which we know that they are still giving us a challenge, if you're new to this channel, please make sure that you subscribe so that you won't miss our classes that we shall be working with. Okay, so that's it, guys, from Maths African Motives. Till we meet again, let's continue to share, like, share, comment. Let me know the areas that we need to work on as a family. Maths African Motives. Till we meet again.